Far beyond the everyday experiences of our world lies a hidden realm, a reality so strange, so mysterious, that it challenges everything we think we know. Here, particles can exist in multiple places at once. Time and space bend in ways we barely understand, and the act of observing can alter the very fabric of reality. This is the world of quantum physics, a world where the universe dances to the rhythm of probability, uncertainty, and interconnectedness. In today's journey, we invite you to dive deep into this enigmatic domain, where science meets the unimaginable, and where we may just begin to unlock the secrets of existence itself. Our understanding of the physical universe has always been shaped by the laws of classical physics. For centuries, the theories of Isaac Newton and his contemporaries provided a clear and deterministic view of the world. Objects moved in predictable ways, forces acted uniformly, and the cosmos seemed to operate like a vast, well-oiled machine. But as scientists probed deeper into the nature of reality, into the tiniest building blocks of matter, they encountered phenomena that defied all expectations. Classical physics could not explain these anomalies. The first cracks in the old paradigm appeared in the early 1900s, and from those cracks, a new theory began to emerge: quantum mechanics. It was Max Planck who first proposed that energy is not continuous, but instead comes in discrete packets, quanta. His revolutionary idea was the first step into a new realm of physics. Soon, Albert Einstein expanded on this concept, using it to explain the photoelectric effect, where light, thought to be a wave, also behaved like a stream of particles. This dual nature of light, behaving as both a wave and a particle, was the first glimpse into the strange rules that govern the quantum world. From here, pioneers like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger took quantum theory to unimaginable heights, each new discovery revealing more of the enigmatic nature of the subatomic world. With the birth of quantum mechanics came a revolution in how we understand reality. The world of the very small, the world of atoms, electrons, and photons, does not follow the same rules as the macroscopic world we experience. In fact, the behavior of particles at the quantum scale is so counterintuitive, it seems more like magic than science. Take, for example, the famous double-slit experiment, which demonstrates the mind-boggling nature of quantum particles. In this experiment, a beam of light is shown through two narrow slits onto a screen. When both slits are open, an interference pattern emerges, as though the light is behaving as a wave. But when individual particles of light, or photons, are sent through one by one, they still form an interference pattern, even though no two particles interact with each other. The real mystery comes when we try to observe which slit the photon passes through. The moment we measure the photon's path, the interference pattern vanishes, and the photon behaves like a particle again. This bizarre result suggests that particles only choose a definite state when we observe them, otherwise existing in a superposition of all possible states. One of the most intriguing aspects of quantum physics is the concept of superposition. At the quantum level, particles do not exist in one location or another, like the objects we're familiar with. Instead, they exist in multiple states at once, each state representing a possible outcome. It's only when we observe them that they collapse into a single, definite reality. This idea raises profound questions about the nature of existence. If particles can exist in multiple places simultaneously, could it be that entire realities, entire universes, are playing out every possible outcome? This is where the interpretation of quantum physics starts to blur the line between science and the philosophical. To illustrate this paradox, Erwin Schrödinger devised his famous cat thought experiment. A cat is placed in a box, along with a radioactive atom that has a 50% chance of decaying and triggering a poison release. Until we open the box, the cat exists in a superposition of being both alive and dead. This example, although hypothetical, highlights the bizarre nature of quantum mechanics. Perhaps the most perplexing phenomenon in the quantum world is quantum entanglement. When two particles become entangled, their states are linked, no matter the distance between them. If you measure the state of one particle, the other particle's state will instantly align, as if they are communicating faster than the speed of light. Einstein himself was deeply troubled by this phenomenon, famously referring to it as spooky action at a distance. He couldn't accept that entanglement didn't violate the speed limit of the universe, his own theory that nothing could travel faster than light. But as experimental evidence has consistently shown, quantum entanglement is a real and verified phenomenon. And though it seems to defy the laws of classical physics, it is an integral part of the quantum world. Entanglement hints at a deeper, more interconnected reality, one where the boundaries of space and time become less rigid than we once thought. Another key feature of quantum physics is the concept of uncertainty. Introduced by physicist Werner Heisenberg, the uncertainty principle states that we cannot simultaneously know both the exact position and the exact momentum of a particle. The more accurately we measure one, the less we know about the other. This uncertainty is not due to flaws in our measurement devices. It is a fundamental aspect of the quantum world. In the macroscopic world, we take for granted that objects follow predictable paths, but at the quantum level, particles exist in a state of probability. We can only calculate the likelihood of where a particle might be or how fast it's moving, not both with absolute precision. The implications of the uncertainty principle challenge our classical notions of determinism. In the quantum realm, there is a fundamental limit to how much we can know about the universe at its smallest scales. Despite the abstract and mind-bending nature of quantum mechanics, its applications are transforming the world in very tangible ways. Quantum theory has given rise to technologies that are reshaping our future. From the development of quantum computing, which promises computational power far beyond anything we can currently imagine, to the potential for quantum communication, encryption, and even teleportation, we are just beginning to tap into the possibilities of the quantum world. Quantum computers, for example, leverage the principles of superposition and entanglement to perform complex calculations that would take classical computers millions of years. These machines are still in their infancy, but the potential they hold is staggering. From solving the world's most complex problems to revolutionizing industries like medicine, finance, and artificial intelligence, quantum computing will likely be at the heart of the next technological revolution. Another exciting frontier is quantum communication, which uses entanglement to create secure, unhackable lines of information transfer. Scientists are even exploring quantum teleportation, where information is transmitted instantly across space, thanks to the entangled states of particles. The mysteries of quantum physics are far from fully understood. In fact, we are only scratching the surface of what this strange and beautiful science may reveal about the nature of reality. As we continue to explore the quantum world, we may find answers to questions that have eluded humanity for centuries. Questions about the origins of the universe, the fabric of space-time, and even the nature of consciousness itself. But with each new discovery, more questions emerge. What is the true nature of the wave function? Are there hidden variables, as some physicists propose, that explain the randomness of quantum mechanics? Or is reality itself inherently probabilistic, as the Copenhagen interpretation suggests? Some theorists believe that quantum physics could hold the key to unifying the four fundamental forces of nature: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, into a single theory of everything. Perhaps it is through quantum mechanics that we will one day understand the deepest truths of the universe, from the birth of the cosmos and the Big Bang to the ultimate fate of space and time. In the end, quantum physics is more than just a scientific theory. It is a window into the most profound mysteries of existence. It challenges our perceptions, forces us to question the nature of reality, and opens the door to infinite possibilities. As we journey further into this quantum realm, we may discover that the true nature of the universe is even stranger and more wondrous than we can currently imagine. And in doing so, we may finally begin to understand our place within the vast, interconnected web of existence. Thank you for joining us on this journey through the quantum universe. If you enjoyed this exploration of science and wonder, don't forget to subscribe to our channel, Light at Night, where we delve into the most intriguing and thought-provoking topics of our time. Stay curious, stay inspired, and as always, keep exploring.